Just the two of us. We can make it if we try. Just the two of us. Just the two of us. Just the two of us.
What controls the constant speed range of a constant speed propeller? So, engine RPM, angle of climb and descent with accompanying changes in airspeed, the mechanical limits in the propeller pitch range. What controls the constant speed range of a constant speed propeller? Definitely not the RPMs. Angle of climb and descent with accompanying changes in airspeed. No, the mechanical limits of the propeller pitch range. Well done. Mechanical stop in the propeller hub limits the constant speed range of a constant speed propeller. So that's the answer. It was good. Next one. Okay, next one. Which statement is true regarding a thermocouple cylinder head temperature measuring system? The resistance required for cylinder head temperature indicator is measuring farads. The voltage output of a thermocouple system is determined by temperature difference between the two ends of the thermocouple. When the master switch is turned on, thermocouple indicator will move off scales to the low side. Okay, so what's the answer, guys? The voltage output of a thermocouple system is determined by the temperature difference between the two ends of the thermocouple. That's the answer. Let's read it. Which statement is true regarding a thermocouple type cylinder head temperature measuring system? The voltage output of a thermocouple system is determined by the temperature difference between the two ends of the thermocouple. Okay, it was a good one. That's the answer. If you want to check it, you can just stop the video and read it. That's good. What prevents pressure within the lubricating oil tank from rising above or falling below ambient pressure? Reciprocating engine. I know that is the oil tank vent. We checked the answer, and yeah, to ensure proper tank ventilation at all flights are used. Reciprocating engine oil tanks are fitted with vent lines. Okay, that's good. Next one, the use of less than normal throttle opening during starting will cause. The use of less than normal throttle opening during starting will cause a lean mixture, a Riggs mixture, a backfire due to lean fuel air ratio. A Riggs mixture. Don't play with that. Okay. The position of the throttle valve determines the amount of air that flows into the engine. When an engine is static, a high vacuum is created on the engine side of the throttle. Therefore, if the throttle valve opening is less than normal at this time, the high vacuum will draw excessive fuel from the idle jet and create a richer than normal mixture. That was a good one. Next one. During ground operation of an engine, the cold flaps should be in what position? We already learned that. They should be a fully open position. Cold flaps are small doors at the rear of an engine cooling that are used to vary the amount of cooling air that flows through the engine compartment. When an engine is operated on the ground, the airflow through the cowl is limited due to the lack of forward motion. Therefore, to keep the engine from overheating, the cowl flaps should be placed in the full open position to allow the maximum amount of cooling air to flow through the engine compartment. That was good. Next question. The procedure for removing the accumulation of air deposits on compressor blades is called the soap method, fuel cleaning, the purging process. That is called fuel cleaning. Compressor fuel cleaning is the process of removing an accumulation of contaminants from compressor blades. Okay. Where are the high and low pitch stops of a Hamilton standard constant speed or two-position counterweight propeller located? In the hub and blade assembly, in the counterweight assembly or in the dome assembly? The answer here is in the counterweight assembly. Let's check the answer. The high and low peak stops of Hamilton standard propellers are located in the counterweight assembly. However, in some of the more modern constant speed propeller assemblies, the peak stops are located in the dome assembly. That was a good one. What is the purpose of a turbocharger system for a small reciprocating aircraft engine? Compresses the air to hold the cabin pressure constant after. No, with the cabin, it doesn't make sense. Next one, maintain constant air velocity in the intake manifold. No, compresses air to maintain manifold pressure constant from sea level to the critical altitude of the engine. This is the answer. So, as an aircraft gains altitude, the decrease in air density causes a decrease in engine power output. One way to help maintain sea level pressure within an engine is to use a turbocharger that compresses the air before it enters the engine, thereby maintaining sea level air density and manifold pressure up to the turbocharger's critical altitude. Next one. To determine the flow level in a flow-tight carburetor, measurement is usually made from the top of the fuel in the flow chamber to the. So, let's go to understand this question.
To determine the flow level in a flow-tight carburetor, a measurement is usually made from the top of the fuel in the flow chamber to the
parting surface of the carburetor. Second one is top of the float, and the third one is center line of the main discharge nozzle. So, to determine the flow level in a flow-tight carburetor, measurement is usually made from the top of the fuel flow chamber to the. I would say parting surface of the carburetor. I don't know really. Yep, that's the answer. So, to determine the flow level in a flow-tight carburetor, a measurement is usually made from the top of the fuel in the flow chamber to the parting surface of the carburetor. The answer or explanation: the flow level in a flow-tight carburetor is determined by measuring the distance from the top of the fuel to the parting surface of the carburetor body, or the point where the flow chamber separates. Okay guys, it was hard. A Fuel Authority Electronic Engine Control (EEC) is a system that receives all the necessary data for engine operation and adjusts the standard hydromechanical fuel control unit to obtain the most effective engine operation. Develops the commands to various actuators to control engine parameters. Controls engine operation according to the ambient temperature, pressure, and humidity. What do you think, guys? What do you think? Let me just do something here. Okay. A Fuel Authority Electronics Engine Control (EEC) is a system that receives all the necessary data for engine operation and adjusts standard hydromechanical fuel control unit to obtain the most effective engine operation. I should say that yes, develops the commands to various actuators to control engine parameters. Yes, controls engine operation according to ambient temperature, pressure, and humidity. What does make more sense? I don't know. Who knows? Adjust the standard hydromechanical fuel control unit to obtain the most effective engine operation. I would say this one. Why? I don't know. I was lucky. A Fuel Authority Electronic Engine Control (EEC) performs all of the functions required to operate an engine. In other words, it receives data from the aircraft and engine systems and then issues commands to various actuators that control engine operations parameters.